Well, I was out here in the garage tonight, working on a little window unit, trying to see if I could bring it back to life. And I've concluded that the compressor is locked up. But I thought I'd make a quick video showing you how I came to that conclusion. Uh, well, first of all, this is one of these newer window units that have these stupid circuit boards in there. And all the time these relays and stuff are going bad. And I've got another video on my channel where you can just bypass all this stuff and get one of these window units up and running again if you have a bad circuit board. So search my channel, you'll see that. I'll try to add that into the notes. So I thought I was going to do that with this one, but after I got digging into it, I found out the compressor is doomed. Let me show you how I came to that conclusion. So if you got working on a window unit, you can, because it would just sit and hum, and eventually would the thermal overload, this little device here, would kick out. Now sometimes a bad capacitor could do that. Sometimes you can add a hard start kit. And I'll show you how I'm about to do that also, just to confirm everything is no good. So anyway, first of all, we start out with, find out our terminals. If you look really closely here, you can see that says run, start, and common. And get your little piece of paper, draw it out. So we got common to start. So we've got 4.6, and then we go from common to run. Well, it's 1.4. I wrote down 1.3. It keeps fluctuating a little bit on me. And then we want to measure between run and start. So move this around to run and start. And 5.7, 5.6. She must have a loose connection. Hang on. Straighten up. There you go. 5.7, 5.8. All right, which I have that wrote down also. Okay, so that owns that. That looks good. So the way to determine this, you add your start to common, 4.6. You add your 1.3 common to run. You got 5.9. This is 5.8. We're just one tick off. So the windings look fine. Our start windings, our run windings. Internally in the compressor, they're not broken. There's one more test we could do while we're here, is check for a short to ground. I don't suspect, I know it's not the problem, but we'll show you how you do that. Well, I should have mentioned before, in doing this test, you take your meter and set it to your ohms. And this is a great meter, this field piece, SC440. If you're going to fool around with electronics and stuff, this is a great tool to have. So let's switch it over here to another setting. Okay, so I've got my gauge set up here. So we still just leave it on ohms resistance. And you can tell if I put my alligator clip here right on the copper pipe, you see I've got a direct connection, very little resistance. But when I check these terminals, it should stay OL, each terminal. So there is absolutely no shorting on all three of those. Check all three. We have no short. It's not going to ground. So we know internally this compressor is good to go. All right, so now let's try a hard start kit. Okay, so one last test before I condemn this thing. These hard start kits are very handy to have. This is a RCO410. Use these on refrigerators, all kinds of stuff. So I've got it wired up. It's real simple to do. It tells you exactly white, black, red, start, common, run. And that's what I've done. But also, if you look on your compressor, it will tell you, there's a little white sticker back in there. And on that sticker, it tells me lock rotor amps is 35.5 amps. So I'm going to try to turn this on. And first of all, because I got this great little tool that measures something called inrush. And it will freeze the amp load. Because sometimes it happens so quickly with a fraction of a second, you really can't catch it just by measuring amps. So that's what makes this tool so special to me, because it has that feature. So let me see here. I get to push a button here, go select. On the side, we hit inrush. All right, so now I got to hook this up where I can turn on the switch and see it at the same time. Well, I was going to show you here for my quick test how I wired this up, loosely and dangerously, of course. So I've just got the two power leads. Well, just like this schematic. Let's start here. So that tells you to hook it up. 110 volts here, red, black, white, common start run. So I just got me a heavy duty cord, coming up here to a power strip so I can just flip that switch on briefly for my test. I thought I'd show you exactly how I wired it up before I kick it on. Okay, see there, 37 amps. So we're going higher than lock rotor amps is. And I heard the little thermal overload pop as soon as I did that. So that pretty much condemns this compressor. She's locked up tight. Who knows, it could have sat around so long, a bearing seized up, maybe a piston broke. But something internally is definitely wrong with this compressor. So I will scrap this little one. But anyway, that's one way you can check to make sure for certain that your little air conditioner is not repairable. This one is not. Sometimes we get lucky, sometimes we don't. Thanks for watching. See you, bye.